Now we have the floating point types. Now we've already talked about those ones in the previous video, and these ones only have three, and they are called the float, the double, and then the long double. And as well, it is dependent on the spacing. Right, so let's go ahead and then quickly illustrate this with an example. So I'm creating a variable called n1, and it's going to be a data type of float n1, and I'm equating it to 98e98, and I hope you know what this means. This just means 98 times 10 to the power 98. Right, so this is what this just means. So let me add a semicolon here before it throws an error. And so I just want to print this out, C out N1, print this one, and then you ENDL over here, right? So let's go ahead and run this Shift B, and we get infinity, right? What this tells us is that this particular variable, 98 times 10 to the power 98, it's so large that it falls outside the range of float numbers. So to better understand this, let's store the same value, but this time using the keyword double to store n2, and we equate it to the same value, which is 98 e98, and this time I used the capital E. It doesn't really matter, it does the same thing, right? So we go ahead and then we print this out, n2, and this is going to be ENDL that way, Shift B, and now we have the number displayed. Now over here, this number falls within the range of doubles, but it falls outside the range of floats. So if you have a number that is so large, then you are advised to use double, or you can use the long double to have much room to store that particular variable, because the floating range is so little, it's so small. So that's why infinity was returned over here, right? So we can create a third variable called the long double. So the more the when you come down this order, float double, long double, the precision increases. Yeah, so that's basically what it is. So we create a third one, n3, and then we want to equate it to the same value, 98 e98, right? And then we come down to print it, n3 endl, right? So we print this, and we have the same number, 98 e to the power 99. Okay, so now if it fell within the range of doubles, then it should fall within the range of long doubles. And I want to believe when we increase the exponents and all of that, and it will get to a point that it will fall outside the range of double, and we can only use a long double. Now this explanation over here, yeah, we've already talked about this. So a 16-bit unsigned integer would be able to represent 65536 distinct values in the range of 0 to 65535. But then a signed integer would be able to represent half of this for negatives and half of this for positives. Yeah, so that's what it really means. Now we'll talk about operations on strings. We've talked about strings, an introduction to strings in the previous video. Now we just want to do quick operations on it. So let's create a string called string sentence I love to code. So this is a string we have created. We have declared the data type, and the variable is called sentence, and we are storing this in it. I love to code. So if we call this out, cout sentence, right, you know what's going to be displayed. Just going to be simple, I love to code. So I love to code, right? Now what we want to do to this variable, what we want to do to this string, is to perform certain operations on it. For example, we can get the size of it. So the format is sentence dot size and then endl. This allows us to get the size of a variable by using the dot operator. So whatever size you want to find, the variable is sentence, so sentence dot size, right? So it's a dot size something, so it's always a dot operator. So whatever you want to find, the size of dot size. So let's just run this and see what happens. So we have I love you, and we have 14 over here. So the size over here is 14. let's go ahead and count these characters one by one. So we have 1, 2. So this is 1. The I is 1. Then the space is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So what the size does is that it returns the number of characters, right? And this is same as cout sentence dot length. I hope I spelled that right. Sentence dot length. So it returned 14 as well, right? So let's look at what capacity does. So cout sentence dot capacity endl, and we have 15 over here. So let's see what capacity does. Capacity is, so I'm just copying this definition from the internet, and this is what it says. Paste. So it says that capacity is the maximum. Let me uncomment out this so that you see what is written. So capacity is the maximum number of characters that the string can currently hold without having to grow. Size is how many characters actually exist in the string. So I think this is for efficiency, memory efficiency. When you look this up, I think I got it from Stack Overflow. So you can look that up if you are interested in getting to know the difference between capacity and size. So I just delete this and then we continue. Now, the second thing I want us to do is append. Append helps us to add something to the end of a string. So let's say that I have sentence. The sentence was I love to code. If I use append, what it allows me to do is to add something, a string to the end of that variable. So let's just go ahead and illustrate it with an example. So over here, I had sentence.append in C++. So let's run this and then we talk more on it. So the last one was this one, and the sentence is I love to code. This is a sentence. So I love to code, and then we added in C++, right? So what it did was it added in C++ to the end of sentence. So that's what append to append means, right? Now we look at the second way, which is sentence.append do you do to. So at this juncture, let's print out sentence to see what actually is stored in it, because we have added something to it. So sentence now has been updated. So we run this and we see that the sentence is now I love to code. First we printed a sentence and it was just I love to code, but now it is I love to code in C++ because we added something to it. So sentence is no longer just I love to code, but sentence has now been updated to I love to code in C++, right? So let's get that right. So if we are appending something to it, we will be appending to I love to code in C++, not just to I love to code, I love to code, right? So over here, let's run this line of code. And I wrote these out before this tutorial in order not to waste so much time thinking of what to do, what example to use, right? So let's run this line of code, which says sentence.append do you too, right? So these extra numbers over here tells us where exactly to append and how much to append. So let's run this and then explain it using from the result, right? So over here you see that we have do you do too, and it's just I love to code in C++, you too. Now what happened? Where did the do go? Where did the do go? Now what we need to know is that this first number over here tells us where exactly to start appending using this particular string. So we start numbering from 0 to 1 to 2 to 3, then to 4. So the space over here is the first character, which is 0. Then the D is 1, 0 is 2, this space is 3, and Y is 4. So when you add this number, it tells the computer that pick this string to append, right? But then start on the fourth index. And on the fourth index, step 7 times. So 1, 1, 2, 3, 4, 5, 6, 7. So after the fourth, on the first index, step 7 times after the fourth index, and then append it. Don't append everything. I want it. So we are telling the computer to append just a portion of it so you can tell it what to do. Right, so let's run this again and see the output. And so we have, I love to code in C++. So the do was omitted and then U2 was added, but then there was no space. There's no space here. So let's see what we can do to add space over there. So what we can do is we can add space over here in the former one, right? So I just added space here so that when this one gets added, this space would be already existing. So let's run this and see. And now we have space over here. So I love to code in C++, U2. Even though this does not make meaning, I just want to illustrate a concept and I hope you got it. Right, so the next thing we want to do is to use append in a different way. Now what this does is it goes to the end of the sentence. So let me comment out all of these. So right now, since this line of code will not run on the next building and running, sentence is just going to be I love to code. Note that. So before that, let's print out sentence to see what we are really working with. So see out, right. So let's print this out and see what we're really working with. So the sentence is I love to code. Oops, let me go back and clear out all of these ones. So we have a string sentence and we are printing that out, which is just sentence. And what we're doing over here is to append this, right? So it's like we are appending this character, dot character, but then this parameter tells us that we are putting 10 units of them in there. So let's print this out. Let's run this and see the output. So we have a string I love to code, and then we have these characters which have been added 10 times to the end of it. So that's what this one does. So we could have used an exclamation mark and we run this and it's going to return that 10 exclamation marks have been added to it, right? So that is the application of the append. So then we want to talk right now about insertion, how to insert a piece of string into another or a character into another string. So right now we have a new string over here called S1 and it just stores I am coding. So let's go ahead and print this out to see what we're really working with. So we're printing out S1, ENDL, and we have I am coding, right? So that's what we're working with. Right, so the insertion allows us to not just add to the end of the code as append does. Insert allows us to get into the middle of even the string to add whatever string that we want. So let's see how we can do this. So we can do this by using the dot insert. So cout s1 dot insert. And what do we want to insert? We want to insert. Okay, so the first thing we want to specify is where exactly in the code, in the string, this string, do we want to insert whatever we want. So we want to insert let's say over here. So let's count the index. This is 0, this is 1, this is 2, this is 3, this is 4, this is 4. So we want to insert at the 4th index, right? And what do we want to insert? We want to insert in C++. So let's go ahead and run this to see if we need to make any modification. So the string is I am coding, and then so I am is over here, and then the coding is over here, and this is what we just inserted in C++ in the 4th index. But you can see that there is no space over here. So what we can do is we can add space before the string so that the space will be included within whatever we want to add. So we run this again to see the output, and now we have I am in C++. So in C++ was inserted into this code I am coding. Yeah, even though this does not make much sense, I hope you get what we want to communicate. Another thing that we can do is with this insertion, after we specify where exactly we want to insert and after we specify what we want to insert, let's say that this is a long string, like let's say C++ is a fast language, right? So this is a long string, but then we don't want to insert everything. So what we can do is we can specify from where exactly we can start the insertion and from to where we want to end it. So over here we want to start at, let's say C++ is a fast. So we want to start from C++ is a fast lang. We want to start from C and then end on T. So what we can do is we can start at the index 0, right? And then end at index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, around 13 over there. Yeah. So let's go ahead and run this to see if we want to make any further modification. And we have I am so this is the variable I am coding, and then I am coding is over here, and what we just inserted was C++ is a fast, so it was left with T. So what we can do is we can shift this index to 14, right? So we have C++ is a fast being inserted into I am coding, right? So the insertion was done right. So that's all about insertion. Now we have the replace, how to replace something within a string. So we have a string called S4 and it says I love Python. Now if we want to replace Python with C++, how do we do it? So this is how to go about it. Cout S4 dot replace, and we put whatever we want to replace in here, right? So over here we want to, within this string, right, within this string it's called I love Python. Now from where exactly do we want to start our replacement, and from to where exactly do we want to end? So we want to start on the seventh index, and we want to end on the we want to start on the seventh index, and we want to step this 7, 8, 1, 2, 3, 4, 5. Yeah, we want to step 5 times, right? And then what do we want to add? We want to put in C++. We want to replace that particular something. We want to replace that particular space with C++. Let's go ahead and run this, and would talk more on it when we from the results, right? So now we have I love C++, but the N was still there from the Python. So what we can do is we can shift this to 6. So now what this line of code does is it takes this S4, which is I love Python, and then we want to replace a portion of it. So we want to specify the particular portion that we want to replace. So we want to replace from the 7th index. So this is the 0th index, first index, second, third, fourth, fifth, sixth, and the P is the 7th. So we want to start from the 7th index. And how many steps do we want to move? We want to move 6. So 1, 2, 3, 4, 5, 6. Right? So we have specified where exactly we want to replace, and then we come and specify what we want to, what do we want to replace it with. So we want to replace this entire space that we just specified over here with C++, and that's what exactly we did. Now there is one more thing that we can do. Let's say that we have C++ is a fast language again. It's a fast language, but then let's run this and see what the output is going to be. I love Python, and then the Python was replaced with C++ is a fast language. So I love C++ is a fast language, but that's not what we want to do. What we want to do is to replace it with just C++. So what we can do over here is to specify on this replacement string, right? On this replacement string, where exactly do we want to start and where exactly do we want to end? So we want to start on the 0th index, that's on the C, and we want to move 3 indexes to the right. So it just start from the 0th index, which is C, and we move 3 spaces over here, 3 indexes. So 1, 2, 3, right? So let's run this and see what the output is going to be. And now it's just I love C++, right? So that's how to go about it. So when you have a string that you don't need to use everything, you can specify after that, and then this shows where you want to replace in the previous string. So I go ahead and comment out these ones, and we move on to the next one, which is the erase, to erase a portion of a string. So this is a string that I made, and it's called, this is a test string, right? Now you know how to declare these strings already, so there's no much to talk about that. Now, what I want to do is I want to erase a portion of it, right? So what I can do is I can use cout to print it out to the screen, and it's going to be s5 dot erase. Now, what the parameters that I need to put in here is where exactly do I want to start erasing? So that's the first question. Where exactly do I want to start erasing? And I want to start erasing from the, so I just want to output this is a string. So I want to start erasing from t. And t, what is the index of t? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's on the 10th position, right? So that's where exactly I want to start. And then I want to move 4 steps to the right because I want to delete this entire thing. So I move 4 steps to the right, and then that's it. So let's go ahead and output this and see what it does. And now this is a string was printed. The previous string was this is a test string. Now this is a string was the output. Now, so that's how to erase a portion of a string. So I'll go ahead and comment out all of these. And then the next thing that we want to look at is at. Now, you could have, you might have been like, okay, so anytime we want to index, we have to count and count and count. And that's really disturbing. Like it's not convenient to do, it's not comfortable to do. And it's mostly trial and error because you call an index and you end up calling the wrong index. So what we can do to check this is, let's say that I have a string O here, right? Let me even replace this with, this is a test string. This is a test string, right? So this S6 is now, this is a test string. Now I want to eliminate this test, right? So what I can do is the previous way was to count to the first letter, but then I can use this command. Yeah, so I can use this command to quickly get an approximation of the index that I should be targeting. So let's say that I just look at it and then I say x is at 6. So what value is at 6? So let's run this before we make further explanations. And at 6 is s. So what this does is that it picks the sixth index, which is 0, 1, 2, 3, 4, 5, 6. It picks out the string, and then at the sixth index, what character is there? So that's what this line of code does. It picks out a string, and then it outputs the value at the character at the nth index, in this case at the sixth index, and it was an s, and that's not what I wanted. So I could just count, so 6, 7, 8, 9, 10, and then put 10 over here too. So we go ahead and run this, and we get t over here. So we now know that the t is the 10th index. This is not even an efficient way of doing it. So let's look at a second, the most efficient way of doing this indexation, as you might want to call it. Now, so over here I have, so what we'll be using over here is the dot find operator, right? So over here I have a string called s7, and it's just, I love to code using code blocks, right? Now I created a second variable called letter, and it's just a character, data type character, right? And it's storing a u. Now what I want to do over here in this next line of code is to call out my string and then use the dot find operator to find the letter u. And what this does is it outputs the index of the letter I want to find. So let's go ahead and run this line of code to see what is going to be returned. And this returned 15. Now what this means is that the letter U is on the index 15 within the string S7. So let's go and then count manually. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is the U on the 15th index. And this is a more efficient way of doing it. So let's say that within this particular string, which was S6, we could have just said cout s6 dot find and then we put in, what do we want to find? Test. So dot find t. So output that index for us so that we use it to work. right? So we go ahead and run this. Let me comment out all of these ones. And now we get 10 over here as we manually did count. So we manually did count and then found it at 10. And then this one as well is returning a 10. So this is a more efficient way of getting the index than manually counting. So just look at the letter that you want and then you find it. But a problem arises when, let's say, I want to find this O over here, right? I want to find this O over here. Now there are several O's. There's one O which came before that, before this, and even there's one over here. So when I say cout s7.find, let's say O, okay, let's leave this as letter, and then we replace this variable, the value as O. Now let's see what this is going to return. This is going to return. So let's run this, and we get 3, right? But that's not the index I was looking for. I was looking for, let's say, this particular index, right? This is the particular index I was looking for, right? So how can I get this index when there are several before it? Now what I can do is I can pick out the word that letter is in, and it's in the letter code. Now I can replace this with code. So find code. Where is code occurring? So we run this, shift B, and we get 10 on the 10th index. Now let's see if that is true. On it, and you might have seen that there are two codes over here. So now this C is on the 10th index, but that's not the particular C I am looking for. I am looking for this particular one. So how do I get to this one then before I can get to the O? The way how I can do this is to use the most recent word that comes after the one I am looking for, which is using. So I can instead look for using. And then run this. Even though there will be more efficient ways of doing this, this is just to get our hands on practice as a beginner. So it returned 15. Now that means that this U is on 15, right? So I can then count to O. Or another way of doing it is I can search for the letter G and then count 3 spaces to O. So let's search for the letter G instead. So the letter G, and we run this, and we have 19. So G is on 19, and then 19, 20, 21, 22. So O should be on 22. And in order to verify that, let's use the the at operator to find out if it's on the 21st index. So s7 dot at 21st index, and we want to end line over here. We want to print this. Oops, sorry, s7, not st, s7. And we run this, and we have C. So the 21st index is C. Let's change it to 22nd, right? So we run this, and now we have O, right? So that's what we were looking for. So we got what we're looking for. So that's how to use the find operator. What we want to do right now is the .r find. Now what this does is it returns the index of the last character that we're looking for. Yeah, so that's S7. Let me uncomment this one, and we run this to see what is going to return. So it returned 29. Now what this means that the last C is on the 29th index. Now there is a C over here and there is a C over here, but the r.r find returns the last index of whatever we're looking for. If we just use s7.find C, is going to return the first index of its occurrence, but the .r find returns the index of its last occurrence. Yeah. So let's find the last occurrence of O in there. So this is O, and let's run this, and we expect it to be more than 22. So it's 28 over here, and yeah, we're right. So that's how to use the .find operator. And then right now the last thing we want to look at is back method. Now what this does is, let's say I have a string called str and it stores simply hello world. What the back method does is it picks the string and then replaces the last character with another thing that we want to do. Now It doesn't entirely replace, but you can replace it if you want to. So let's say we just want to print out cout, then we have str dot back. Let's see what that's going to return. ANDL, right? So we run this to see what is going to be returned, and we have a full stop over there. So now what the dot back does is it returns the last character of that string, and the last character over here is a full stop. Now what we can do is, let's say we want to replace this character, we can use the replace method, or we can just use str dot back. What this does is it just returns the last character, right? But then want to reassign that last character to a new one, which is just an exclamation mark. So right now when we print out the new string, which is just str, we're going to get the last character being replaced by the new one that we just entered. So let's run this. Oops, I should put a semicolon over there. We run again, and now we have the full stop being replaced with an exclamation mark. Right. So that's some commands that we can use with strings. You can look up more of these ones from the C++ reference. Yeah. So there is pop back, there's pushback, there's rbegin, there's replace, and all of these ones there's copy as well. That you can copy portions of string and even entire strings. Yeah. So that's it for strings, and I hope this video was really useful for you guys as beginners. I hope it really helped you to know some of the things that you can do with strings. So this is just a quick introduction to strings. Yeah. And before I close this particular tutorial, you might have seen that this message gets appeared encoding in whatever. That's because I was including the Russian characters. So let me go ahead and then I delete all of those characters. I don't know where they are right now. Yeah, so I'm going to delete all of these ones and then these ones as well. And now let's run this to see whether we'll get the same message. And now the message has not appeared. So it was because of those Russian characters. And you could see that the message said it changed from U to UT8 whatever. Yeah, it's because of those characters. And the system adjusted itself for those characters. Yeah. So that's it for this. See you in the next video.